Binary logistic regression with an ordinal predictor in SPSS. Binary logistic regression is a statistical method that can be used when there are two variables. One of the variable is called the outcome or the response or the dependent variable. This outcome variable have to be binary, which means that there are only two categories in the variable. Either you have diabetes or no diabetes, smoker or no smoker. The other variable, which is called the predictor variable or the explanatory variable or the exposure variable or the independent variable, can be a continuous variable, can be a categorical variable, can be ordinal variable. Ordinal predictor is a categorical variable that have classes in it or categories, but these categories are in order, such as the age classes. The logistic regression can be used to find out whether there is a relationship or association between the outcome and the predictor, and whether the predictor can predict the outcome and the variation in the outcome can be explained by the predictor, in this case the ordinal predictor. Here in this SPSS data view, I have two variables and there are 200 cases here. Those two variables are the age categories and diabetes, whether you have a diabetes or no diabetes. The age category is an age that has been arranged or sorted into categories. The first category is an age of 16 to 24. The second one is 25 to 45. The third one 46 to 70, and the last one is greater than 70 years old. So this variable is categorical variable, but it is ordinal more precisely, as it has categories in it, but there is an order. 16 to 24 is the first, and then 25 to 45 is the second. So this variable is a ordinal variable. The second variable is diabetes, has only two levels in it, two categories, so it's binomial or binary variable with either yes, you have diabetes, no, you don't have diabetes. So here we have two variables, one of them is binary, the other one is ordinal. So the age category is the predictor and the diabetes is the outcome. So to find out whether the age categories can predict the outcome, which is whether you have diabetes or not, or whether increasing the classes or categories of age can increase the chances or the probability or the likelihood of getting diabetes, then binary logistic regression can be used. And since the conditions are satisfied, that we have two variables here, an outcome which is binary for diabetes and ordinal predictor which is the age categories. This logistic regression will determine whether there is association between these two variables. Before we proceed to perform the test, let's do some statistical descriptive. Click on Analyze, scroll down to Descriptive Statistics, Frequencies, reset this, drag the age categories and diabetes to the box for variables, click on OK. Multiple tables are generated. The first one shows that there are 200 cases for the age and diabetes, the two variables, no missing values here. The next table is for the age categories from the first category from 16 to 24 up to greater than 70. There are 50 cases in each category. And for diabetes, there are 119 cases of no diabetes and 81 of having diabetes. In fact, before we proceed to the test, let's look at the coding for the variables. For the first variable, which is the age categories, 0 is assigned for the first category from 16 to 24 and 3 for greater than 70. So this value here, 0, will be taken as a reference category for comparison in the logistic regression. For the outcome, which is the diabetes, 0 for no and 1 for yes. Back again to the data view here. To perform the binary logistic regression with a ordinal predictor and a binary outcome, click on Analyze, scroll down to Regression, select the binary logistic regression, reset this. Since the diabetes is the outcome, drag that to the dependent box here, and the age category, drag it into the box here. As shown here in this box, any variable can be dragged in, whether it's continuous variable, whether it is binary variable, whether it is ordinal variable. And since the age categories are categorical, there are 4 categories in it, drag that into this box and select the reference category, which is the first, in this case the 0, which is 16 to 24, will be the reference category to compare to. Click on Continue, then click on Options, select the classification plots, select this goodness of fit test and confidence interval for the exponential p-value. Click on Continue and then click on OK. Multiple table will be generated and a diagram at the end, which shows that the predicted probability is of a membership for yes. Back again to the top here, as shown here, the first table shows the case processing summary. There are 200 cases, no missing cases. The second table is coding for the outcome, which is the diabetes, yes or no. Yes for 1, 0 for no. And the next table is for the ordinal variable with the age classes, with the frequencies and the number of cases in each category. Moving to the classification table, again shows those cases with diabetes and those without diabetes. The next table is variable in the equation. B stands for the coefficient, SE for standard error, Wald is the test used for logistic regression, degree of freedom, significant value is taken as p less than 0.05, and exponential p. The most important, in fact, section is the one start from here, in which shows that the model summary. This is an important table. This model summary, this value here, R square, is the one to look at, which says or states that or describe that 25.5% of the variation in the outcome, which is diabetes, can be explained by the age category or the ordinal variable. Moving to this section here, we need this value to be greater than 0.05, and the important table to focus on is this one, the variable in the equation. Again, this table as shown here in the section, this is the variable for age categories. The age category which is assigned a 0 value is considered as a reference, which is from 16 to 24, as not shown here. But the age 1 is for 25 to 45, age category 2 is for 46 to 70, and the last one is greater than 70. The coefficient is given for each one of them, the standard error, the degree of freedom, significance, and as shown here, all the 3 categories are significant, less than 0.05, and an exponential value p value is given here, and as we can see, an increasing value with increasing classes of age, getting older. And then 95% confidence interval is given for each value for the odds ratio. This exponential p is the odds ratio, and here we have two layers of determining whether there is significant or not p-value and the 95% confidence interval. From these significant, it is well shown that there is association or there is a relationship between having diabetes or not compared or relative to the predictor, which is the age category. So there is association between these two variables, and the predictor, which is the age classes, can predict the outcome, whether which is in which you probably have a diabetes or not. The way to interpret the result is that those who have an age category from 25 to 45 years old have increased likely of getting diabetes compared to the younger group. The odds ratio is 3.14. In another way, those with a category of age from 25 to 45 have an increased odds of 3.1 to get diabetes compared to the age group, which is from 16 to 24. The second category, which is age cat 2, in which the age category is from 46 to 70. Again, the odds ratio is 7.3, so this one is higher than the previous one, and the third one is also higher. So there is a trend of increasing odds ratio with increased age classes. Again, for the age category 2, those with the age from 46 to 70 have an increased odds of 7.3 relative to the reference group, which is a younger group. So there is an increased chance of getting diabetes with increased age. And finally, for the individual who are greater than 70 years old, they have an increased odds of 17.11 to get diabetes compared to the younger group. So the oldest individual have a higher odds, higher probability, higher likelihood of developing diabetes compared to a younger group or younger individual. So this is the way to interpret the output from a binary logistic regression for an outcome that is binary and for a predictor that is ordinal in SPSS. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, R Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.